Hi, I'm here with Pat Murray from Anritsu, and we've got instrumentation behind us that computes a differential noise figure. Now, Pat, a lot of viewers probably know what noise figure is. I'm not sure they all know about what a differential noise figure is. Can you go into that a little bit?
So on differential noise figure, then you have normally doing single-ended noise figure measure, which is measuring the noise basically of an amplifier. Now everything is moving to differential measurements, so you'll want to be able to do that in real time with a differential setup. So you'll measure both paths at the same time and calculate out or compute the noise figure of both paths together.
And what kind of applications do you really need that for?
So for those, anytime you're doing amplifiers, or LNAs, you want to measure the noise figure of the amplifiers, basically. So active devices for the most part.
Well, you've got a demo set up behind us. Why don't we go through that?
On this VNA particular setup, then we have a differential noise setup. So basically, we're measuring a DUT, so an amplifier basically that has a differential noise figure or correlated noise figure across the paths. In today's current industry, we're measuring single-ended measurements. So we're taking a single-ended measurement of one path, and we're taking the single-ended measurement of the other path, so for the noise figure measurements, and then we calculate out or combine those paths and do that post-processingly and calculate out the differential noise figure. Okay, but you really want to do it now because those are really easy to do and nice to do with a lot of isolation in your devices. So noise isolation. But now you've got to deal with the noise correlation that goes between inside the amplifiers. So to do that, then you need basically two paths that are going to get powered at the same time and driven at the same time. So we use two composite receivers externally, and we run them into the B2 port and the B1 port of the VNA. We measure the DT so we can get the SMP file of the DUT. We characterized the composite receivers. We do a calibration for receiver cals at the end of the composite receiver so we know what the noise levels are of the VNA. And then we insert the DUT and measure the differential noise figure in real time. The other technique that Anritsu offers inside the VNA, besides the uncorrelated and the correlated, is the using a balun or a splitter of some sorts. And it's common today to use a balun where you can bring in two signals inside the balun and come out as a single-ended signal, and then treat the circuit as a single noise figure measurement. Characterizing a balun becomes a problem, and a lot of people don't characterize the balun to remove the effects of the balun. So inside of our VNA, we characterize the baluns up front. We de-embed the baluns to get a more accurate one. It's much simpler and easier and more accurate to get than using a balun.
What's difficult to do about a differential noise figure measurement like this?
The reason why it's a difficult measure to make is because you have to have both samplers and everything turned on at the same time and looking at the measurement real time at the same time. Typically it's a calculation that gets done inside or post-processing, and then you display it. So the results are not real time. So by doing it in real time or differentially real time, now you can get real time data in seconds compared to longer time. Yep.
Well, that's interesting technology, Pat. Where can people go to get more information about this?
Go to Anritsu.com website or talk directly to a sales engineer in your territory. So, but the website's the easiest place to get information. Yep.
Great.
Anritsu.com. Yep.
Thank you.
Well, sure. Thanks.